Welcome to my YouTube channel. So here today we are going to be looking at 79 questions which will equip you for networking. So let's begin. So the first question says that what is a network? So a network in simpler terms is just the connection of two or more devices connected together. So if we have, let's say, device 1, device 2, device 3 or device 4, when these are connected, let's say by a cable, they form what we call a network because they are able to share information. So a network is just an interconnection between two or more devices. The second one says networks allow sharing of. So networks allow sharing of, number one, we have the hardware, we have the software, and the data. Now you might be wondering, how does network share the data? Let's say we have computers connected like that, then we have a printer. So you will find that through these computers they will be able to share this hardware, in the sense that if, let's say, you want to print out something that is from this computer, you are able to print out from the printer. Or if you have something on this computer, you are able to print out on this on this same printer and all that. So they are able to share software, they are able to share hardware, they are able to share also data, meaning to say you can transfer data from this computer to the next, like that. And also software in many organizations, they are able to use one software to be able to access many computers, or rather many computers can access one software. So the network is able to allow the sharing of software, data, and hardware. Then when we look at digital communication, so this is very, very simple. Digital communication, digital just has to do with something that has to do with data, or rather that has to do with a computer. Now digital communication is just, if we look at this, is just the transfer of data between devices, because that is communication. So digital communication is the transfer of data between devices. When we look at this, the device that initiates data transmission is, so initiate simply means to say to start. So the one that initiates data transmission is what we are going to call the sender. Then when we look at this, transmission media refers to, so transmission media, so transmission meaning to say to allow something to pass. So now transmission media is just a path for data transfer. So it is the path, so it is the ability to more like allow certain things to pass through. So among these options, transmission media is the path for data transfer. The examples that we might have are cables, we might have different optic fibers, or optic fibers and all that. So a transmission media is just a path or a channel that allows the transfer of data. Then looking at 6, a modem is, so a modem, so remember the definition of the modem. Modem, when we look at MO, that's modulation, and DEM is demodulation. So a modem is able to modulate and demodulate, demodulate. So a modem is able to modulate and demodulate. So the modem is able to allow devices to be able to be connected. So a modem is mainly used for the communication, as a communication device. Let me shed more light on that. So now a modem, like for example, if you are looking at the internet, which is a series of interconnected computers, then here you have the modem there. Then let's say you have a signal from the internet, then here you have a computer. Let's say here you have a computer. Now what the modem does is that we know that a computer can only understand ones and zeros. So when the signal comes, this signal is converted to zeros and ones. Let's say here, if it is 1, here it's a 0, so that the computer can understand this this signal that came here. So if the signal was like that, it is converted by the modem so that the computer can be able to understand. So a modem is used as a communication device through modulation and demodulation. Number 7, the home network is, so a home network simply allows a small number of people or individuals to be able to access or use. So a home network is used by a few users. When we look at a business network, on the other hand, it is able to allow a lot of people to be able to access, because it's a business and just for the sake of more like record keeping and all that. So therefore, a business network, let's say, handles small data and support many users, should be able to support many users so that they can easily be able to more like update the system of the company. Now, when we look at number 9, which is not a benefit of home network. So home network, let's look at our options. So we have sharing internet, sharing files, sharing printer, managing large companies. So which one is not a benefit? So already managing a home network cannot be able to manage large companies. Number 10, so it can be able to be used to share printers, how we print, like that. It is able to share files, share the internet, but you cannot manage large companies. It is limited. When we look at number 10, intranet means, so intranet, so intra means private. So the intranet is an internal private network. Now, where does it work? So an intranet is an internal private network within an organization. So if we are looking at an organization, they will be able to be using what we call an intranet. They will be able to share data and information securely as a company. So it is secure in the sense that it is just within the organization or company, like that. So the intranet allows individuals or the company to be able to share, number 1, data, collaboration, and also just generally internal communication. If a message is sent, they are able to use the intranet to access that as a company. So it is used to internal private network within an organization. So these options are not done within an organization. So which makes the next question the opposite. So number 11, extranet allows access to. So extranet allows access to, number 1, it allows access to customers and suppliers. So it is able to allow those customers of the company to be able to access. It's not everyone, it's not like the internet, but the extranet, like the customers and the suppliers to be able to access certain information. The extranet is able to do that there for the customers and the suppliers. So the answer here is, we have our B there. Then when we look at our 12, VPN stands for virtual private network. So the VPN is the virtual private network. So the VPN is very important, as it is used for secure remote access. Like for example, if you don't want to be discovered where you are, there is, let's say here there is a VPN tower and you stay very far. Instead of you sending things on the internet, you can be able to connect to a VPN, which is able to encrypt or rather hide your data by tunneling it like that. So your data is able to pass through like that, pass through and reach the VPN location. So if anyone on the internet wants your information, what happens is that There, the IP address that will be able to show, which is the identifier of address, will be more like the VPN's address will be what will be shown as where you are. In the actual sense, that's not where you are. So the VPN is a virtual private network. It's very, very important as it offers encryption of data. So if you want to send data securely, use a VPN on the internet. Looking at 13, wired networks use. So here we have use airwaves, use cables, are slower, are less secure. So wireless network, wired networks, wired meaning to say they use a wire, so therefore they use cables like that. When we look at our 14, on the other hand, wireless means without the use of a wire. So wireless use radio waves. It can be radio waves or it could be the airwaves that we are here. So the wireless do not use a conductor or a wire, therefore they use radio waves to transmit. So just the waves of the radio waves like that. One thing that you need to know about wireless connection is they don't use cables. Also, they are not always secure. Like for example, Wi-Fi on the internet might not be secure. They are slower than wired. That is wrong. They are mostly faster. When we look at our number 15, we have 3G, 4G, 5G are. So these, when you are turning on your data, you may realize one thing that it is able to show, which is cellular. So they are cellular networks. So 3G, 4G, 5G, these are cellular networks. They are called cellular networks because of the towers that are able to provide networks, which are cell towers like that. So in different regions, they are around. So these towers are around in different regions. They are able to provide data like that. If you are here, you are able to communicate with someone that is there through these towers that provide the network. So they are called cellular networks. When we look at the topology, what is topology? Topology has to do with the physical arrangement. So topology, though these definitions are not done, but topology is the physical arrangement of networks. So it is the physical arrangement of networks. So how is the networks arranged? Remember, network is the interconnection of computers. So how are they arranged? That is what we call topology. Now, when we look at, so the answer there is the physical arrangement. When we look at number 1, in a bus network means you can just think of it as people trying to get on a bus like that. So we have one computer here, we have one computer here like that. Then we have one computer here, we might have the next computer here. So the topology, the topology of this is the topology, which is the arrangement of the bus network. So when we look at it like that, so a bus network, number 1, devices connected in a circle, no, devices connects to the central cable. So as you can see, this is the central cable, so the answer there is B. Now a mesh network, on the other hand, you can just think of a mesh as something like this. So if we have a mesh of something, we might have all the computers being connected like that, so to form more like the network like that. So this is a mesh. So now the mesh network has all the devices interconnected, so you can just think of it as a mesh. So if you have a mesh, you have something that is scrambled like that. So a mesh has got all the devices interconnected. This is why it is able to produce what we call redundancy. Redundancy is the ability to more like resist faults. Like for example, if one computer cable is not working properly, let's say this one, the it will be able to access the internet still because it has got many parts. But for this one, for the bus, if this is not working, then the information will not be able to reach the internet like that. So therefore, that is the main difference. Mesh has got devices. All the devices are interconnected with each other, offering multiple paths. Then when we look at the ring network, this one, the ring network, so a ring network, you can just think of it as a ring like that. So the ring network might look like something like this. Then these are connected. There is sequential data flow, meaning to say data can flow from, let's say if it's flowing from here to here to here, this is a sequence, so this is sequential data flow. So that is the ring network. So it is forming a ring like that. So even this one, if one device fails, then it can disrupt other devices. So that is the ring. Now when we look at the star, it might sometimes look like a ring, but it has got one central thing, which might be a switch or a hub. So we might have a switch. Let me use a different shape. We might have a switch or a hub. So if you recall, when let's say if information is sent from here up to here, if we have a hub, immediately it reaches the hub here, the information is sent to all the computers like that. Now a hub is not secured, but if we have the switch in the middle, the switch, if you want, let's say you want from this computer, you want the information to go here, a switch will only send to the computer you want, but the hub will be able to send to all the computers. So therefore, we are here, we have a star has got a central device present, which might be a hub or a switch. 21, clients or server network. These, so the clients or server networks uses servers. So now this is very, very simple in the aspect that a client is not necessarily a person in this regard. So a client is simply a computer or a device that is receiving resources or information. So which leads us to this question. So a server, machines that can be used as a server, you might have let's say a mainframe computer. So now if you have a mainframe computer or any computer that is large, it stores a lot of data. So this one acts as what we are going to call a server. It stores information which is able to supply the information to other computers like that. So that is basically a server. So in this regards, these computers will be clients because they are receiving resources or data. So a client is a device requesting resources. So the one receiving resources or information or files, that is what we call a client. Peer-to-peer network is a type of network where the two networks are equal computers, where both of them are acting more like a server and a client, meaning to say they are able to share information. This, let's say A and B are able to share information from here up to here, then A is also able to share some information like that. So the computers are equal. You can just think of it peer to peer, as if we are looking at peer pressure, we are looking at people of a similar age, so they have to be equal in age. Looking at our next question, it says LAN stands for, we have the local area network. So this is able to cover an area which is the local area network that is within the 100 meters. So places can be able to share the network or information like that. Now when we look at one, the coverage of one, already one means wide area network. So this one is able to more like cover large areas, geographical areas such as countries or continents. MAN on the other hand is metropolitan, and metropolitan you can just think of it as a country. So we have metropolitan area network, which is the MAN. So this one is a city, not a country, but a city level. So this is a city-wide network. So a city-wide network is what we call MAN, which is metropolitan area network. When we look at 27, PAN, which is the personal area network, connects. It is able to connect personal devices such as phones with Bluetooth. We might have earpods and all that. We might have AirPods, among others. So AirPods are able to connect through the personal area network, which covers a few meters, such as maybe even 10 meters away. You are able to connect things such as Bluetooth. 28. Network standards define. So already it's a standard, and this standard is useful for the rules for network communication. What are some of the rules that you are able to have for network communication? What are some of the things that you can post on the internet and all that in network? So that is what we call network standards, how you are going to use the hardware that you have and the rules of communication. Number 29, we are looking at the protocol defines what we are going to call the communication rules. What are you going to be considering as you are communicating? Then when we look at Ethernet is a cable. It is a cable, so it's a physical cable. So therefore, Ethernet is a wired type of a standard. So it is wired because it's a physical cable. Then when we look at our TCP and IP is used for, so TCP and IP address is useful for what we call internet communication. So what is this? So we have TCP is what we are going to call transmission control protocol. Then when we have our IP, we are looking at internet protocol. So the internet protocol is the IP, and TCP is the transmission control protocol. So let's begin with our IP. So IP is more like it is an identifier, a unique identifier that will be able to allow, let's say, the internet to know exactly where to send the information. So that's why I said with this IP address, people are able to know exactly where you are, because even the internet is able to know exactly where to send the internet, the data packets, information and all that, depending on where you are sending your information from. Then when we look at the transmission control protocol, this one controls or makes sure that the data packets are sent exactly where they need to be sent. So in short, it helps the data to reach the internet, the IP address. So the internet protocol, now the IP address where someone is sending the information. So this transmission protocol is able to help in that. So it helps in the reliable delivery of data between devices like that. Then when we look at our next question, we have IP address is, just as we have said, it is a unique identifier for a device. So it is a unique identifier for a device. So that device that you have, the information for it to reach a device, it must be identified. That is where the IP address comes into play like that. So a IP address is a unique identifier for a device. There might be a lot of devices, but the information that you have, let's say, searched for is able to reach you because of this same IP address. Otherwise, we could have a situation whereby another device is the one that is getting the information, but it is very much unique like that. So if we look at the examples of IP addresses, we might have IP4, IPv4, and IPv6. So these are examples of protocol types, with one, the IPv4 having 32 bytes, then the IPv6 having 128 bit address, the one like that. So moving on, due to the many bytes that, or rather bits that this one has, it is more and more secure and also just efficient. Now when we look at so the answer there is this. When we look at our number 34, we have Wi-Fi is. So Wi-Fi, what is Wi-Fi? So Wi-Fi is wireless fidelity. So this one allows computers to be able to connect wirelessly. So Wi-Fi is an example of a wireless standard. When we look at our 35, Bluetooth is used for, we have the short distance communication. So as you know, the longer you are, the more the communication becomes poor, or the connection. So when something is very, very near, that is when the Bluetooth will work. Sometimes that is when the Bluetooth will work properly, or even work because of that aspect. When we look at our 36, we have our IRA, DA, and what does it use? So IRA, DA means, so that is what we call infrared data association. So infrared data association. So this one uses what we call, it uses infrared light. So a common example that we might have is a remote. So if you look at the remote, a remote is able to send infrared lights that you are not able to see. But if you point your remote on the camera and press something, you will see the light that it is able to show. That is an example of infrared light. Then when we look at the RFID, so one thing about, before we move on, our IRDA, this one has to be in the line of sight. Like for example, you need to point at where you want the, more like there to be a response. But for RFID, this one is the radio frequency identification. Radio frequency identification. Now this radio frequency identification, this one is used to identify certain materials. Like for example, in a very big company, it's not every time that they will have to manually be able to count things. Like for example, it's not every time that they have to count the number of clothes that are there and all that packaged in a thing. No, they will use the radio frequency identification. So each and every cloth will have what we call an identifier, which is a unique identifier for that cloth. Let's say of that size. If it is the same type, there will be a lot of cloths of this size in one package. Now what this does is that it will be able to identify, so let's say if it is put here, it is able to identify at all areas different materials that are there. This makes even counting and record keeping to be very, very easy by identifying the number of items that are already there. Like for example, if we are looking at a very, very big company, you will have clothes, you will have a lot of things that needs to be identified. Let's say in this compartment there are a lot of things, in this one, in this one, in this one, and there are a lot of boxes. It's not that you are going to be counting manually. You will just use this type of technology in which each and every item is more like identified with a tag. That tag is able to more like give the information of what item that is. Like, let's say if these are reams of paper, it will be able to say that there are 25,000 reams of paper. So now this makes it very, very easy to do record keeping, and also reduces manual work. There are a lot of items, and also animals can be identified on their location using this technology by attaching a tag on them. So this type of information, or this type of technology, uses what we are going to call a radio signal. So it uses radio signals. So even the next one, which is our near field communication, this one also uses radio signal, but it is just it is NFC, which is the near field communication. So NFC is near field communication. So the near field communication communicates over a very short distance. So now this is used, let's say, for cards such as those cards that they use. Let's say if we have an elevator, which is a secret elevator for that matter, or a restricted area, there happens to be a point at which, let's say here, where you are going to be putting your card, in which if you press your cards there, if you swipe your cards there, it is able to allow you to access that location. So that is an example of a near field communication. You just get your card, you press it there, and it is able to read as you press it there. It is able to open. So that is an example. So it's using radio waves. So it is based on the radio frequency identification. Then when we look at our hub, if we have the connection, remember we have talked about the hub. If we have the connection of computers like that, when they are connected by wires like that, when the data passes through this hub, it is able to send the information to all the computers. So this type is not that secure, and so a hub is number A, sends data to all devices, sends to a specific device. Then we have, so it sends information to all devices. This, on the other hand, a switch, which is more reliable and effective, sends data to intended devices. Just as I said, for example, if you have this computer, we have the switch there. So if you send information, let's say from here to here, you want the information to go down, it will just send to that computer so that you can see, like that, unlike the hub. So number 41 says a router. This one, the router is able to connect networks. So what we simply mean is that, let's say if we have the local area network like that, for the information to be more like sent to the internet, we might have a router. Sometimes we might have, let's say, we might have a modem like that. So a modem will convert these ones and zeros, because the information from the computer will come like that, which are zeros and ones, like that, zeros and ones. So this information is converted into an analog signal, which the router will be able to now convert to the internet. So the internet is able to access this information by the use of a router. So let's say if this is the internet, which is the globe. So you might think of the internet as the globe like that. So this globe will receive information via the router, or the router can you can remove network, or you can remove data from the internet, passes through the router, passes through the modem to be able to convert it to the language which the computer can understand, which are zeros and ones. Then it goes like that. So that's why they say that a router routes the network. So just as I have said, a router is a networking device that connects two or more networks and routes data between them. Now this is important because between them, it is able to route data between them. When we look at our 42, we have modem connects. So the modem connects a network to the internet by the conversion from the language that the computer can understand, which is ones and zeros. Then our 43 says that cable modems use. So these are examples of TV cables. So this specific cable is what we call coax. So coax, which I'll write later, just showing the image. So if we have the coax, which is this one, many of you have seen this on the Go TV or the DSTV. Just as you can see, this is an Ethernet. It's a physical cable. Then so this Ethernet is able to connect. So this is what we call a coax cable. Many of you have seen it. Here it is. So we have the coax cable like that. Inside it has got something. So yeah, so that is mainly what a coax cable is. When you more like remove the outer part, you will see something like this. So that is a coax cable. So that is an example of what we call a TV cable. So modems uses TV cables. Then when we look at the next one, which is our DSL. So DSL is what we call a digital subscriber. So this subscriber, then here we have the line. So we have the digital subscriber line like that. So this one is made up of telephone lines. It is used to provide high-speed internet access over just the ordinary telephone lines. So as we can see, we have the DSL filter. So it uses telephone lines to connect like that. So as you can see, so remember, it is digital subscriber line, which is a technology that provides high-speed internet access over just ordinary telephone lines like that. So these are the telephone lines that we are talking about. Then we have the FTTP. So this one is termed as fiber to the premise. So that those are the initial meanings. So we have the fiber to the place or premises. So what we have there is this one uses fiber optics to produce or rather give very high speed internet connection. Remember, fiber optics has to do with light, so it uses light to be able to transmit the network like that. So just as you can see, this cable, this is the fiber to the premise. It provides to your home like that. So it is very, very important and very, very fast like that. Though expensive, but it's very, very fast. Remember, we have the copper wire. For it doesn't use copper wire, but it uses fiber optics. More like they are made of reflective surfaces inside that cable to produce very, very fast network. So these run from the internet, the ISP, which is the internet service provider, to direct to the home. Internet service provider is the one that provides the network. When we look at the next one, we have multiplexing. So what is multiplexing? So multiplexing is simply the combination of signals. You can just think of it as the word multiply. So multiplexing is the combination of signals. Like let's say if we have, so we might have the signals like passing through these channels, then these signals are combined to pass through like that, then they are divided. So that is multiplexing, which is just a combination of signals. When we look at our next one, which is saying that a dedicated line is so dedicated. If someone is dedicated, that means to say it is always on connection. So that is a dedicated line, because dedicated is always on duty. When we look at our number 48, it says that network setup requires, so the network setup requires these two things. Some routers are inbuilt, but we have the modem and the router. The modem, which converts the information that the computer releases, which are zeros and ones, into analog signals, which when the router, let's say, is here, it is able to now send digital signals to the internet like that. Then when we look at our SSID, so the SSID is just a service set identification. So service set identification. So this service set identification is useful for a network. It is just the identification for a network name. So the name of the network is called the service set identification. So it might be Wi-Fi. Like, let's say if you name your Wi-Fi to be home Wi-Fi like that, so that is the SSID, which is just the network name that you have set. So it is good to put a unique service set identification name so that you don't get confused when you're trying to access your Wi-Fi. Then when we look at our wireless key, so a key is a password. So a wireless key is simply a wireless password. When we look at our next question, when we look at our next one, we have our 15. So what is an adware? So you remember the ads, those that pop up when you want to watch something, you just see another video. So an hardware is a software that shows unwanted ads. You do not intend to watch that ad, but it comes. So that is an hardware. Spyware is a software that is able to track data without permission. So that is a spyware. So it's a software that tracks data without permission. It is able to monitor what you're doing on your computer without your permission. When we look at a virus, what the virus does is that it damages data or alters. Alters means to say it changes data. So as long as something changes data, then that is called a virus. Changes or damages data. Then when we look at a worm is self-replicating, self-spreading or self-replicating that causes damage to the computer. So worms are self-spreading. Then when we look at Trojan horses, which is, this is not complete, we have the Trojan horse. The Trojan horse is a software that more like hides malicious, meaning to say dangerous programs, and itself it disguises itself as legitimate, meaning to say the real deal, as if it's not a malicious program. So that is what we call a Trojan horse for that matter. When we look at our ransomware, ransom simply means to say for you to access, let's say if someone has been arrested, if someone has been kidnapped, people will ask for ransom, or rather the kidnappers will ask for ransom. So this is the amount of money that you pay in order for you to access certain things. So what this does is that the ransomware will lock the system until information, or rather until maybe you reveal the information, or unless you pay the hackers the amount. So that is the ransomware. When we look at our 57, the rootkit. So to root, we know to say root means to steal. So if there is rooting, that simply means to say that there is a lot of stealing. Many people are even destroying shops and all that. So a rootkit, this one, what it does is that because when you go in a shop, no one is even there. It's the conditions are that everyone is rooting. So anyone who goes in their shop, they can take whatever they want. So they will act as if they are the owner of that thing. So therefore, a rootkit gains admin access. So they gain certain access that can only be done by the admin, who is most of the times the creator of, let's say, the software, which is not supposed to be gained. So this one, it helps gain admin access, but at the same time it hides its presence. You cannot be able to see it like that. So just a reminder of an example of the worm is I love you. So this is an example of a worm. So just one word connected. Then when we look at our next question, we have encryption is scrambling the word. So like for example, my name is Steven. Then if we scramble the words like this, we might have something like this, let's say N-E. So this scrambling of the words to more like for security, so that people do not know that name. That is what we call encryption. So encryption requires the scramble of the data in order to secure the network or information. The next one is a firewall. So you can just think of the firewall as a wall. So this one, the firewall just blocks unauthorized access. So a firewall is a software that blocks unauthorized access. So how it works, it's like this. So if we have, let's say this is the firewall, information from the internet is filtered, or rather blocked by the firewall if it is not from a trusted entity or a source. Therefore it will not be able to reach your computer like that. Therefore it secures your computer in that sense. So that is the working of the firewall. When we look at authentication, on the other hand, authentication has to do with just the identity verification, like entering passwords and all that is what we call authentication, because you are trying to show that you are the one who is accessing your computer. Biometrics has to do with the physical, or you can use the face. So we are using mostly the physical features when we are using biometrics. So we have the fingerprint, the face, the facial recognition can be used for biometrics. Then when we look at our NAS, which is the NAS provides, so NAS simply means network attached storage. So the network attached storage, it stores the network in the sense that in a central place. So like for example, this is a big computer with which other computers can be connected like that. So in that sense, this one provides the information which these other computers can be able to access in that manner. So they are able to access in that manner. So the network attached storage offers the central storage like that. So this central storage can be accessed by other computers in that regard. Then when we look at so it is able to share the network using the internet. So that's why it's called the network attached storage. So this can access the storage that it has through the internet, this and that. So this is what we have. When we look at our next one, we have a monitoring software. So a net monitoring software, so it's monitoring, so it is used to track the network status. So this is very, very important, as it helps you determine how good is your network connection. We look at the packet sniffer. So you can just think of the packet, to sniff is to smell. So a packet sniffer, what it does is that it monitors traffic. Then when we look at our 65, the network administrator. So an administrator is someone who manages something. So a network administrator just manages the network, and also they maintain the network. So that is the function of the network administrator. So when we look at our number 66, which is Usenix, is this one is just a non-profit organization. So it is a non-profit organization for network professionals. When we look at our next one, this is a simple one. Ethics include, so ethics are just the professional conducts, what you are expected to more like behave, the professional way of behaving, those are ethics. When we look at our 68, WLAN is so W in this case is wireless. So we have the wireless LAN. Then when we look at the tree topography is simply, so if you look at a tree, it has got branches. So these branches, you can just think of them as being a tree or star, like that. Then we have the central. Remember, the central has to do with the bus, then the star. So it is a combination of a star and bus, like that. So that is what makes up the tree topography. So that is the connection of our computers, remember that. Then when we look at our 70 is if central devices fail in star. So remember how we were drawing our star. So our star might look like something like this. So this is a ring. A star has got the midpoint like that. So this, remember, all of them are connected to this device. So if this device fails, which is the hub or a switch, then that simply means to say if the central device fails, then that simply means to say the network will stop, like that. So when we look at our 71, if bus fails, that simply means to say the central point, if it fails, then that simply means to say there will be the communication between computers will simply stop. So remember, that's the bus cable, the central cable there. When it stops, then the communication stops. Under the mesh cable, when the mesh advantage is that it is failure tolerance. Remember, the mesh cable is made in such a way that each computer is connected like that. It is connected. So if one fails, then there will be failure tolerance, meaning to say it will still be able to communicate with other computers. That is the advantage of the mesh. Then the ring disadvantage is that if one fails, then the network stops, like that. So if we have the ring, we have something like this, then these are able to interact like that. If one device fails, then the interaction stops, like that. So therefore, that's the disadvantage. The disadvantage is that one failure stops the network, like that. When we look at our 74, switches are preferred over hubs because of they are efficient, in the sense that they are able to send information to an intended device. So if there is a switch there, remember a switch, we have something like that. If you send one data here, if you want the data to go from here to here, it will be able to send. But for the hub, it will be able to send to all, even people who do not want to hear the secret, like that. Then when we look at our LTE is used in cellular networks. So you will see that when you turn on your data, you will see LTE. Then we have our ultra wide band. So ultra wide band is so just as the name entails, so we have ultra wide bands. So the ultra wide bands uses very low radio waves at wide frequencies to be able to identify things accurately. So it is effective. So it is effective over narrow distances, like that. It can be used to identify or track certain things. So that is the ultra wide band. So it is short range, high speed. It is able to detect a lot of things. It can also transfer data very, very fast, unlike Bluetooth. So for it, it's very, very fast, accurate tracking of an object position and all that. Then when we look at our 77, network risks include, so our network risks include, so we have antivirus, malware, printer. So network risks, malware is something that is dangerous. So mal simply means to say something bad. Then when we look at our 78, MAC address is, we have the device identifier is what we call the MAC address. So the device identifier is what we call the MAC address. So a MAC address is a unique hardware identifier assigned to a network interface. So so this network interface card, which is also known as NIC, which is network interface card of a device. So it is a unique identifier that can be used to identify each and every device. For example, we might have a MAC address of 001A. Let me wrap this. We have a 001A, 2B, 3C, 4D, 5E, like that. So the MAC address is very, very unique. So due to its uniqueness, it can be used as a device identifier to know exactly where data packets are supposed to go. So that is a MAC address. Then when we look at our 75, network security includes, so weak passwords is wrong, open access is wrong, no firewall is wrong, encryption, remember where we shuffle the letters or information like that. So that's that for networking. Thank you very much for watching. Hope you would like, subscribe, and share for more. See you in the next tutorial.